Hi, my name is Sunaina Abdul Salah, and I'm the product marketing lead for Amazon Redshift and Athena. And I'm joined by Dilip Kikla and Banu Pittimpalli. Today, we're here to talk about why modernizing your data warehouse is imperative to your digital strategy and business growth. I will kick it off and take the opportunity to talk about what we are seeing in the market, why modernization matters, and the role that Amazon Redshift plays. Dilip will then highlight a few of our recent innovations and talk to you about migration. We will conclude with a demo on Redshift migration prepared by our solution architect, Banu. So let's begin. Data is changing the way we work, live, and play. And all of this behavior change and the movement to the cloud has resulted in a data explosion over the last 20 years. The proliferation of IoT devices and smartphones have accelerated the amount of data that is generated every day. Just think about how much data your phone stores versus even 3 years ago. Business models have shifted, and so have the needs of the people running these businesses. At one point, we were talking about terabytes of data just a few years ago to now petabytes and exabytes of data. All of this data explosion has resulted in both challenges and opportunities. Customers are constantly looking to extract more value from more data. Think of the typical sales, marketing, operational analysts, the data scientists, the developer. These users are heavily dependent on easy to use performance systems, and they don't have the skill or the time to be experts in data management or figuring out how to get their analytics tools to scale with the volume of data and the growth in usage. Now, there's also a lot more diversity in the type of data and where the data is coming from. Most of this data is living in different data stores in different departments within the organization. And without a way to integrate and connect this data, create fresh, shared data that is consistent, you can quickly lose the value of data. And finally, how do customers really scale their data systems without losing out on performance or waiting on central IT to tune their systems and prepare the data accurately for them? It's really an instant world today where data systems need to scale up and down to meet immediate or real time demands. If you have a traditional data warehouse, you are probably understanding that it's not really built to meet this changing landscape. Traditional data systems tend to be very rigid, not very scalable, and they need a lot of back-end management.
At AWS, we recommend a modern data architecture to our customers to enable them to store any amount of data in open formats, break down disconnected data silos. We're looking to empower people to run analytics or machine learning using their preferred tool or technique and manage who has access to specific pieces of data with the proper security and data governance controls. We believe in purpose-built analytics because we have seen that one-size-fits-all strategy or a monolithic data system doesn't really work for customers. At the center of this strategy is the scalable data lake built on Amazon S3. Amazon S3 provides industry-leading storage scalability, data availability, security, and performance. And then you have the purpose-built data stores, which may be an operational data store or a data warehouse like Amazon Redshift or OpenSearch service for analyzing log data. We have AWS Glue to effortlessly move data and keep data in sync between all these stores and to provide a data catalog. At the same time, with federated querying available from various services like Amazon Redshift or Amazon Athena, you don't have to move the data at all. You can just keep the data right where it is, and your service can access the data directly from S3 or other stores. And then you have AWS Lake Formation that provides central governance across all these services. And if you want to do dashboards and visualizations, you can use Amazon QuickSight, which is a scalable, serverless, embeddable, machine learning powered business intelligence service that is built for the cloud. Speaking about machine learning, it is one of the most disruptive technologies of our generation, creating new revenue and improving operations. For machine learning to be used more widely, it needs to be brought closer to the data lakes and purpose built data stores, where much of the data needed for ML resides. AWS provides built in integration of ML as a part of its purpose built data stores and business intelligence services. Today, we are going to specifically talk about data warehousing within this mix, which sits at the heart of running analytics at scale for an organization. So, we've talked about why traditional data warehousing doesn't really scale to the data challenges of today. What about what data warehousing should look like? A modern data warehouse is everything a traditional data warehouse provides, but a lot more. It's about being able to conduct real time analytics on all types of data, including semi structured data or streaming data. It's about enabling users beyond your data steward, who is traditionally the data engineer or the administrator, and extending large scale analytics to analysts, developers, and other personas who are now increasingly part of this analytics journey. It's about scaling capacity and storage separately and up and down because users may need intense compute for some workloads, but very little storage, and vice versa. It's also about not having to pay for a monolithic system or for the time you don't use the data warehouse, as we're increasingly seeing variable workloads within analytics environments. As data grows, performance and cost predictability is a very important factor in determining if your data warehouse is working well for you. You need all the parts of the engine humming and in sync, enabling powerful, faster analytics in literally seconds while driving costs down, not up, especially with the scale in data volumes and data usage that we're seeing today. Enabling the best price performance should be a continuous exercise on behalf of the customers. And finally, we have real time and predictive analytics right within the data warehouse that will continue to democratize analytics for new users, for new use cases, such as developers implementing inferences or data scientists who can build and train models right within their data warehouse. At the end of the day, it's all about how this data warehouse can improve operational efficiency and help you make well informed decisions so that you can accelerate your business and accelerate innovation.
Think of the use cases you encounter today with data, no matter which industry you are in. Harnessing insights quickly and with cost efficiency can improve operations or personalize customer experiences. It can hasten your development cycles and bring products to market faster or help you get a deep understanding of where your customers are churning. We are learning from the tens of thousands of customers across every industry and vertical who analyze exabytes of data every day in Amazon Redshift. For example, you can take NASDAQ, ingesting billions of market data into the S3 data lake and running analytics through Redshift. Or Magellan RX, a healthcare service provider that has reduced the cost of running ML predictions by 20% by running machine learning directly within the warehouse. Amazon Redshift has been going through tremendous innovation since its announcement 10 years ago, focusing on three pillars to reinvent itself into a modern data warehouse. Amazon Redshift is a fully managed data warehouse that provides fast, easy, and secure cloud data warehousing at scale. Amazon Redshift delivers easy analytics for everyone with a quick get started experience, so customers can focus on getting to insights in seconds. They don't have to worry about managing the capacity of their data warehouse if they have too many users or there's a lot of spike in data volume. At the same time, customers are looking to break through data silos and move to a modern data strategy to seamlessly access data across their data warehouse, the operational databases, the data lake, and even third party data as they do real time or predictive analytics. And Amazon Redshift helps you analyze all your data. Finally, performance at scale while keeping costs predictable continues to be a critical focus for Redshift to help customers scale to the growth in data and users. Redshift has become a self learning, self tuning system with performance managed by built in ML like Auto Workload Manager and capabilities like materialized views. With RA3 nodes with Redshift managed storage, Redshift delivers up to 3x better price performance compared with other cloud data warehouses. Let's take a look at a couple of examples. Take, for instance, Roche, a Swiss multinational pharmaceutical company leading in cancer treatments. It's very important for Roche to understand their health ecosystem of patients, doctors, hospitals, payers, health communities, etc., so that they can provide the best service to them. They're very excited about making data accessible to their internal business users through Redshift Serverless, which we will talk about soon, and its integration with business tools like QuickSight or Google Sheets, enabling quick but powerful analytics for these business users who are serving these ecosystems. Or we already talked about NASDAQ with vast amounts of market data in the S3 data lake and being able to query this through Redshift's federation capabilities. Finally, a really great example is JobCase, the third largest destination for job search in the United States, and connecting millions of job cases to relevant job opportunities. Here, prediction and machine learning in a scalable, fast way is at the heart of their recommendation engine. With their Redshift built ML models performing billions of predictions right there in their data warehouse, increasing their revenue and user engagement significantly. Now that we've understood the challenges and why we need to modernize to a cloud data warehouse like Amazon Redshift, Dilip is going to talk about a couple of recent innovations that demonstrate the strength of Redshift's capabilities. And he will walk you through the migration journey and successful migrations. Dilip?
Thank you, Sunana. Hello, my name is Dilip Kikla. I'm a global principal sales specialist at AWS for analytics, focused on Amazon Redshift. Having looked at how our customers are benefiting from Redshift, I'll now dive deeper into some of the Redshift features and the customer migration journey. To make analytics easy for everyone, we introduced the new Redshift Serverless option. With Amazon Redshift Serverless, customers can gain insights in seconds without any provisioning or managing the data warehouse infrastructure. They simply load data and start querying. Amazon Redshift Serverless automatically and intelligently scales the data warehouse, meeting varying analytics workload needs with consistently high performance. All users, including data analysts, developers, and data scientists, can now use Redshift Serverless to gain insights from data in seconds. The best part is customers only pay for what they use, which means when the data warehouse is idle, they pay nothing. Continuing with the Redshift features, we launched Query Editor version 2. It is a simple web-based SQL tool to author and run queries in Redshift. You can share queries and analysis with your teammates and visualize results instantly. Moving on, we have customers using Redshift as the single pane of glass for all their data needs. With minimal data movement, they have access to all their organization's data from the data lake and operational systems. With data sharing, they can now share live data securely across regions, across accounts, with no copying. Data sharing is supported, ensuring data sovereignty. With the recent integration of AWS Data Exchange with Redshift, customers can easily find, subscribe to, and use third party data right within their warehouse. This eliminates ETL and manual contracting and licensing for both data providers and customers. Our customers perform ad hoc analytics in Redshift, such as 360-degree views to understand customer behavior seamlessly using data across multiple data stores. And of course, SQL based Redshift ML, launched earlier in the year, has been very popular with customers. Machine learning problems such as predictive maintenance and fraud detection can be resolved through Redshift using SQL. Redshift delivers up to 3x better price performance than other cloud data warehouses thanks to these features. With the support for write queries in concurrency scaling to handle spiky write workloads, Redshift can automatically scale out and back in depending on the number of queries. Customers get an hour of concurrency scaling credits at no charge per day. For customers' fast growing warehouse workloads, Redshift is built to handle this new scale. Features like Aqua, the advanced query accelerator, boost queries up to 10x faster. Redshift team keeps innovating based on customer requests. As mentioned earlier, listening to our customers has enabled us to identify three investment areas: easy analytics for everyone, analyze all your data, and performance at any scale. Focusing on a few features to enable real time analytics, streaming ingestion of data is available. Automatic creation and deletion of materialized views helps with users not having to worry about their query patterns and maintaining the views. With support of semi-structured data types natively in Redshift, customers get better performance. They don't have to worry about learning to administer Redshift, as all maintenance tasks are automated. Redshift Advisor continuously monitors query patterns and updates the data structures without any disruption to deliver optimal query performance. For our new customers migrating over, we have enhanced our SQL support, increased the limits on the number of database objects, and support scripting language in the database. We'll cover those features in detail later on. Customers find the first step for migration always the most challenging. This is because we find that some organizations get paralyzed if they can't figure out how to move every last workload. Our suggestion is there is no need to boil the ocean. For many of you, an iterative approach would be the right one, and we encourage you to take that approach. We often work with organizations to do a portfolio analysis to assess each application and build a plan for which application to move short term, medium term, and last. Once the plan is signed off, a pilot is developed for an end to end migration for the first few applications while developing the customer skills. With those applications in production, this process is repeated for medium term and last few applications. This helps organizations get to the benefit of the cloud for many of their applications quicker, and it really helps them inform how to move the rest. As we work with you to design your scalable, future proof architecture, we ensure you'll have an integrated platform with a centralized governance and security model. Minimal data movement, avoiding copy of the data, and avoiding vendor lock in are built into the design. Through this platform, you'll be able to democratize your data securely amongst your organization to gain a competitive advantage. All throughout the migration journey, AWS is your partner in carrying out the migration, ensuring migration best practices are followed. Your team is developing the required skills. You are leveraging the right program and tools and guiding you along the way. For each of the phases of migration, we have programs in place to save you time and money. First is the analyze and plan phase. Here, You perform data discovery and planning, building a migration business case, and creating a migration plan. Through our data driven everything program, we will bring your business and technology stakeholders together, leveraging a use case framework, develop a go big plan, and a 6 to 9 month roadmap of priority projects. The design lab provides you guidance on real world architectural patterns and anti patterns, as well as strategies for building effectively. The second phase is the workshop and pilot. In this phase, we help you run proof of value and proof of concept to demonstrate the functionalities and performance you get with Redshift. Leveraging the Build Lab program and engagement between you and AWS service experts accelerates the development of a prototype to solve a specific business problem faced by you. Upon completion of the Build Lab, you'll have a functional prototype that you developed, deeper knowledge of AWS services, and are ready for the next step in your migration journey. We also leverage tools like the AWS Schema Conversion Tool or SCT and AWS Data Migration Service that can help expedite this process. The third step is the workload migrations. The Migration Accelerator program packages best practices, expertise, tooling, and financial incentives to make cloud adoption easier, allowing customers to gain cloud benefits sooner. Once you begin the migration, you perform integration, validation and performance, testing, monitoring setup, and the end optimization to get all the cloud benefits. Throughout your migration journey, AWS Data Warehouse Solution Architects, specialist teams, professional services teams, and even partners are available to help you wherever needed. Talking about partners, working with a partner can help ensure you are using best practices and tools. This slide includes a selection, not a comprehensive list, of integration partners that have a packaged Redshift consulting offer for customers like you to get started around their data and data warehouse migration journey. The partners listed here have been vetted to ensure that they have not only the deep Redshift expertise, but accelerators, tools, processes, and references to enable you to migrate from your legacy environments risk free and in the shortest amount of time. Having looked at Redshift features, the migration journey, and how AWS team will partner with you throughout the journey, let me now share with you a few tips and tricks to make this migration seamless. One of the first steps when deciding on a warehouse is sizing it appropriately. You can do this by using the sizing widget in the Redshift console. With Redshift, we suggest size your cluster for your average workloads and we'll take care of the peaks with concurrency scaling. You get 1 hour of this feature at no charge every day. With Redshift Serverless, things become much simpler. To help you improve performance and decrease the operating costs for your Amazon Redshift cluster, Amazon Redshift Advisor is available. It offers you specific recommendations about changes to make when it cannot perform them automatically. Advisor develops its customized recommendations by analyzing performance and usage metrics for your cluster. These tailored recommendations relate to operations and cluster setting. Besides AWS Glue and Amazon QuickSight, Amazon Redshift can integrate with existing third-party ETL tools and other business intelligence tools. Customers want to leverage the rich capabilities of Redshift and migrate over from the traditional data warehouses. To ensure the migration experience is smooth and at a lower cost, we have been enhancing Redshift in various areas, such as SQL syntax to support additional operators. New data types have been added for further flexibility, security enhancements for further fine-grained access control, and various tooling support has been provided as well. Majority of the DDL, stored procedures, and SQL scripts can be automatically converted by the AWS Schema conversion tool. We have introduced operators like recursive common table expression for hierarchical data queries, hyperlog log for count distinct, and pivot unpivot to ease migrations from various databases. On new data types, we support semi-structured data with our super data type, a very common ask from customers that want to ingest and process JSON data in Redshift. We also introduce warbyte support, a popular ask for customers migrating from Teradata data warehouses. The new geospatial data type geography, together with our existing geometry data type, now greatly expands the range of use cases for spatial workloads. We'll now share some best practices on migrations from a few popular on-premises data warehouses to Redshift. We have had customers like FactSet, RetailMeNot, Rovio migrate from Vertica. A few things to note for migration from Vertica are projections should be replaced with materialized views. With the automatic creation and deletion of materialized views in Redshift, now you don't even need to worry about them. Vertica specific functions would be replaced by UDFs. For Netezza and Greenplum migrations, Schema conversion tool greatly helps. As these databases are based on Postgres, migrations are simple. Nielsen's migration to Redshift from Netezza completed very smoothly when working with our specialists. We have learned a lot from migrating Amazon.com from Oracle. All those lessons are part of the SCT, Schema Conversion Tool. One thing to note is that the Redshift primary key, foreign key constraints are informational only. They are not enforced by Redshift. They are, however, used to develop the query plan. Teradata migrations have influenced the Redshift and the SCT roadmaps extensively. McDonald's, Equinox, and other customers have engaged partners and AWS professional services to help carry out their migrations. With their inputs, SCT has been enhanced to take care of Teradata SQL syntax that predates ANSI SQL. Redshift supports case-insensitive tables to support Teradata functionality. Migrating BTEX scripts is a challenge in Teradata migrations. This is addressed with the enhancements in SCT and support for RSQL in Redshift. With a combination of the two, BTEX scripts can now be seamlessly migrated to run on Redshift. We'll soon see that in a demo. I'll now hand it over to Banu for the demonstration of Teradata to Redshift migration.
Thank you, Dilip. Hello, everyone. My name is Banu Pitampalli. I'm a Redshift Specialist Solution Architect at AWS. Today, I'm going to talk about and demonstrate data warehouse migration to Amazon Redshift, specifically how to use AWS Schema Conversion tool to migrate a data warehouse to Amazon Redshift. The solution architecture for the demo is shown here. On the left-hand side, we have on-premise data warehouse along with some ETL scripts developed in the proprietary language. On the right-hand side, we have Amazon Redshift Cloud Data Warehouse. We are going to use AWS SCT to convert the SQL code objects and database objects. We are going to use AWS SCT Data Extraction Agent to migrate data to Redshift Server. And finally, we are going to use AWS SCT ETL Converter to migrate BTEX script to our SQL script. So let's start the demo now. As you can see, the SCT tool is already open on my machine, which is a Windows system. I download it, install and configure the SCT tool as per the instructions found on the product page. It's very easy. You can do it yourself. The first thing I'm going to do in this tool is click on File and click on New Project. And I'm going to call my project as Teradata underscore migration. As you can see, we have the main view where we have sources and targets, which are empty. Then I'm going to add a source, which is Teradata. I have this information pre-populated based on my configuration that I have done. So now I'm going to simply enter my password and name my connection. It's an on-prem Teradata EDW. I'm going to click on store password and connect. I'm going to accept the risk and continue of not encrypting the data since this is a demo. Give it some time here while it connects to Teradata machine. I have successful connection to the source. Now let's add target. Target is going to be Amazon Redshift. Click on next. Again, I got this information pre-populated. I'm just going to enter my password and call my connection. Give it a name, Cloud Redshift underscore EDW. Store password. I'm going to uncheck glue here because we're not using that for this demo purpose. So click on connect. And now I have my Cloud Redshift EDW populated on the target side. Next thing we want to do is create the mapping. Mapping establishes the path for the objects to flow from source to target. So I'm going to go ahead, click on the schema that I want to use for this demo. I want to use the TD migration demo to demonstrate the conversion process. So I'm going to select on that and create mapping. I click on create mapping. Once I do that, the mapping source to target path is established. Then I'm going to go back to main view. Once I do that, you can see the information is again populated. I'm going to uncheck all schemas since we're going to use only one schema. As you can see, we have 10 tables, 4 views, and 2 macros. Go ahead and expand that. We have some fact tables, dimension tables, we have some views, and then 2 macros. So what we're going to do next is we're going to select the schema and click on convert schema. Click S. It's warning if objects already exist, it's going to replace, which is fine. Click on continue. Then now it's working on the conversion process. So the conversion process is where SCT is going to convert or rewrite your tables or views or macros to a format compatible with Amazon Redshift. It is also going to give us an assessment report where you can download and review that to understand how the conversion process went through. To access the assessment report, you can go to main view, click on assessment report view. And here you can see we worked on one schema, 10 tables, and 4 views, or 4 indexes. And when it comes to database code objects, we worked on 4 views and 2 macros. The light green is for the objects which are automatically converted. The darker green for the objects with simple actions. The light blue with the objects with the medium complexity actions, and the darker blue with the objects with complex actions. So today we have 10% of the tables with the medium complexity actions, and the rest went through without any issues. Let's review what those are, and then we'll convert these objects to Redshift side. We can see the issues that have been encountered during the conversion process. I'll go ahead, click on the first issue here. It's about LOA duration column. So once I click on that, we can see that it's coming from the LOA durations table. It's about the interval data type. SCT is clever enough to convert that into character wiring field, since the Redshift doesn't have it yet. Another issue that is reported here is about the view top 5 months. It's about the qualifier rank, and we can see that Redshift is able to mimic the logic with the subquery, and the filtering that is happening with the qualifier rank less than or equal to 5 is now being handled by the where clause, and the view works the same way as the Teradata side, and you get the consistent results. And we can also see that SCT is able to convert some of the macros to store procedures, and you can witness that here. It is also able to apply the case specific or case not specific logic in the where filter. So here in the where clause, you can see that the string par is compared to CI column with a not case specific. On the Redshift side, the same thing is happening. Collate function is used where we're applying case insensitive type. So both the columns are matched irrespective of the case. So there are some ways where AWS SCT really helps you automate your conversion process, avoids manual interventions for you, and makes your migration experience very easy. The next step for us is to apply these converted objects to Redshift side. I have my target side on the right-hand side. This is my schema TD migration demo. It's ready with the converted script, the object. So I'm going to right-click and select Apply to Database. And click OK, click S. Now it is in the process of applying those objects onto my target system. While that is happening, I would show you. This is my client tool, SQL Workbench. I have a connection with my target system. These are our current schemas on my Redshift cluster. I don't see the TD migration yet because it's not created yet. So if I try to select one of the fact table, it says doesn't exist. So the process is still, there it is. The process is done now. And you can check the status by going to, on the target side in the main view, you can check the status by accessing the apply status. So as you can see, the schema, tables, views, store procedures, all have been successfully created onto Redshift side. Now let's go back to my client tool and refresh the dev, the object explorer. Right click schemas, reload it. Now I see my TD migration demo schema now, and I see my tables here, my views. Now when I try to run this query now, it should run successfully, but you don't get any data because we haven't loaded any data yet. Now we move to the next step in the demo. It's about loading the data into Redshift cluster from Teradata warehouse. Step we're going to do is, while in the mapping view, so you get to the mapping view here. So while in the mapping view, right click on the schema, actually on the set of tables here, right click there, and you want to first step is register agent. The registering agent is actually registering the data extraction agent that SCT comes with. So you want to give it a name. So I'm going to call it as a TD agent. Host name, the agent is installed on the local machine, so I'm going to call it localhost, and the port is 8192. This information, you provide this information when you're installing the product, so that's what I remember these, so I'm using them here. And I will uncheck SSL. I'm not using that, and I'll go ahead and register the agent. So accept the risk and continue. Now I'm in data migration view. The agent is registered, its status is active. And once agent is successfully registered, I right click on my tables, and then I will create a local task. The local task is actually, the agent. Now you're creating the data movement task. So I'm gonna name it as TD migration demo schema load. And then I want to select extract, upload, and copy. So the data extraction agent gives you three options where you can extract data to local system, extract and upload data to Amazon S3 or a data lake, extract, upload, and copy data to Amazon Redshift. So in this demo, I'm going to demonstrate how to do all three in one go. So I'm going to select the third option. I don't have lobs in this case, so I'm going to uncheck that. And I'm going to go ahead and create the task. So task has been created. So this is my new task, Teradata migration schema load. I have three phases in this task: extract, upload, and copy. So I'm going to go ahead, select the start. Now, as you can see, the start has initiated extraction process, and then the uploading to S3, and then also running copy commands, which loads data to Redshift, also being in action. So we have completed for many tables. The fact sales table is also finished. Now, if you click on that, it extracted 60,000 rows from source, uploaded 60,398 to S3 and 60,398 to Redshift side. So if you go back to my client tool, if I run this query now, I can see that I have data returned for my query. That's how easy it is to move data from Teradata tables to Redshift tables. Now let's move on to the next step in the process, which is about converting ETL scripts like BTIG to Amazon or SQL. Step in our demonstration is converting ETL script to Amazon Redshift or SQL. In this demo, I'm going to show you how to convert BT script. On the left-hand side, on the source side, at the bottom, there is a section called scripts. Under it, you can see that there is a BTIC option for BTIC, shell, fast load, fast export, and multi-load. These are some scripts you can convert by using AWS SCT. So let me load up BTIC script. So they are in this folder. The script is going to look like this. It has a merge statement. It has a logic based on the row count. If the row count exists, if the rows exist in product stage, then it's going to run this merge statement. Otherwise, it's going to exit. So let's see how AWS SCT is going to convert that script. I'm going to select the folder. It's asking if there are any variables. I don't have any variables, so I'm going to click OK. Then you can see my scripts are loaded. This is my BTIC script here. Now let's get into main view here. And then if you go to the script view here, you can see the BTIC script loaded. In order to script, before you convert the script, we need to set the schema. So the current schema I'm working on is TD migration demo, and hit on apply. Then I go to the script here and right click on the left side. I right click on the script and convert it to RSQL. Click OK. So it identified the merge statement. It highlighted that and it converted the merge statement to update or insert. And the other parts are equally converted to RSQL compatible commands. So it's doing row count and using if logic. If activity is equal to 0, then go to no data. Otherwise, go and run this command. And it also converted labels, remark, everything as compatible with the RSQL. You can save this SQL. I'm going to save it to same folder. It's going to ask me to replace, select yes, and this is how the converted script is going to look like. It has an update and the quit, and same as the BTIC side. In today's demo, we have seen how to connect to Teradata system. We have seen how to convert tables, views, objects from Teradata to Redshift. We have seen how to handle some of the proprietary features from Teradata to Redshift. We have seen how to load the data from Teradata tables to Redshift side. And then finally, we have seen how to convert a BTIC script to Amazon Redshift RSQL script. Now I will hand over presentation to Dilip.
Thank you, Banu. Summarizing, if you are thinking about migrating off your legacy data warehouses, you can leverage numerous AWS programs and capabilities of Redshift to save you time and money. Throughout your migration journey, AWS teams and partners are available to help, ensuring you are following the best practices. Starting with understanding your data strategy and designing a scalable, future proof architecture, we are ensuring you will be able to democratize your data securely amongst your organization to gain a competitive advantage. If you like to dive deeper into migrations, you can download a Netezza self-service guide, review the migration blog, and work with us to migrate your workloads. For more information about Redshift and take it for a spin, go to aws.com/redshift and get started. Thank you folks for watching. Have a nice day.